Okay, let's talk about electrophilic aromatic substitution. So we just spent a whole chapter learning about what an aromatic ring even is. And we learned that it's really, really stable, but we didn't learn how it reacts. And one thing that's really important to note is because it's really stable to have an aromatic ring, it does not react just like a ring full of alkenes would. It has a special way of reacting. Basically, you have to really convince aromatic rings that it's worth it for them to react in order for their aromaticity to be broken and then become destabilized. So usually when we have electrophilic aromatic substitutions, which is how we most often will substitute a hydrogen out for something else on a benzene ring, there are 3 steps. So here's that overall reaction. Benzene starts out as a 6-membered ring with alternating double bonds, really they're in resonance, but each one of these carbons has 1 hydrogen on there. You introduce this benzene ring to an electrophile and overall you get a substitution reaction. You've seen substitution reactions before, but you haven't seen them like this, not on an SN2 and definitely not on an aromatic ring. So because benzene is so stable, you really have to convince it to want to react, and we do that by introducing it to something really electrophilic. In fact, it's usually something so electrophilic that you have to create the electrophilic ion or the electrophilic species in the situation. So that's called in situ. So here are the 3 things I look for whenever I'm doing an electrophilic aromatic substitution or trying to identify it or spot it. First, before we get started, there has to be a way to generate a really positive electrophile, or something that really is okay being attacked, something that will convince benzene to attack it. Then the official reaction starts, the 2-step reaction. And the first part is benzene will attack that super electrophilic species, and it actually creates a carbocation. So it's breaking its aromaticity that's really unstable in order to attack that electrophile. And then in the final step, a base of some kind will come and abstract an additional hydrogen from that same spot, and it will restore your aromaticity. Be sure to look out for these 3 steps.